Next up, Fabric Data Engineering, Python Notebook. Introducing the Python Notebook Preview. This feature aims to improve the workflow for BI developers and data scientists using Python with smaller data sets. The key features are native Python support, version flexibility, optimized resource utilization, lakehouse and resources natively available, mixed programming with T-SQL, superior Python IntelliSense, popular libraries are pre-installed, and seamless integration with the Fabric ecosystem. Notebook Live Versioning. Announcing the launch of the Fabric Notebook Version History feature. This new feature is designed to improve your experience in developing and managing notebooks by providing built-in version control capabilities. Some highlights are automatic and manual checkpoints, track history of changes, comparing different versions, restore previous versions. Notebook Utils Session Management Utilities. Announcing new session management utilities in Notebook Utils. These APIs help manage session and interpreter status. Notebook Utils.session.stop stops the session interactive session via code, available for Scala and PySpark. Notebook Utils Session.restart Python restarts the Python interpreter in a PySpark notebook. Native execution engine on runtime 1.3, simplified enablement and transition from runtime 1.1. A new update simplifies the process of enabling the native execution engine. It can now be activated by toggling a switch, which is in the Acceleration tab within the environment settings. Legacy timestamp support in native execution engine on runtime 1.3. Native execution engine on Fabric runtime 1.3 now handles legacy timestamps, ensuring compatibility across Spark versions. This resolves issues from Spark's 3.0's switch to the Java 8 datetime API from the hybrid Julian-Gregorian calendar. Notebook and Spark job definition execution with service principal. Support for service principals in Fabric API was announced in September. Today, another scenario has been enabled, allowing the execution of notebooks and Spark job definitions under a service principal for data engineering purposes. By using the Fabric Job Scheduler API, users can trigger and monitor the execution of a notebook or Spark definition job. When utilizing the API with a service principal's access token, the associated Spark job will run within the security context of that service principal. Next up, we have a couple of demos from Jean Zhang on notebooks.
Hi, everyone. We are thrilled to share that Fabric has launched the public preview of the Python Notebook. Today, we'll provide a comprehensive end-to-end demonstration on how to utilize this Python notebook effectively. Let's start by navigating to the familiar Fabric Notebook interface. In the Language Selection menu, you'll notice a new addition, the Python Language Group. Upon clicking, the notebook ribbon transitions to a Python-centric view. Let's start by connecting to a live session. The session springs to life in just a few seconds. We can see that Python Notebook is using a mini-sized cluster with 2 vCores and 16 GB of memory by default. We can also monitor the CPU and memory usage in real time on the status bar. Next, we'll load raw customer data from the lakehouse and warehouse. The customer information is stored in the lakehouse delta table, while the labeled churn information is stored in the warehouse table. As always, we can easily drag and drop the data object from the Explorer to read the data. After running the generated code snippet, the customer information is successfully loaded from the delta table. Similarly, we can read the data from the warehouse too. We provide commonly used table operations in the table menu. The Python Notebook supports mixed programming with T-SQL statements, allowing you to easily write SQL queries and execute them in the context of Python. Now, we are going to merge the two tables into a single data frame. Next, let's examine the data to assess its quality. With the built-in display command, we can easily preview the data and inspect its quality. We find some missing values here. Let's clean the data and verify it with display again. Now we can see a much richer view of the display output. Notice that the missing values in the column are gone, and we can see multiple charts reflecting the features important to the churn label. This is because the Python notebook supports persisting chart configurations between each run. Once the charts are saved, you don't need to reconfigure the charts again. We can learn the underlying insights from the statistical results. After the data exploration, we can summarize our observations in Markdown. Based on those observations, we can conduct feature engineering on the training dataset and write the dataset into the lakehouse as a delta table. Now, I'll use my machine learning toolkit to train a light GBM model and validate its effectiveness. I'll define the log settings and experiment name first, and use the pip install command to install the necessary libraries. I can preview and edit the ml_toolkit.py file in the built-in resource folder. Then initiate my machine learning experiment. The confusion matrix tells us that the model works well for task. We can find the inline experiment tracking experience and navigate to the experiment item easily. Here, we can find more useful properties and parameters, and we can copy the run ID easily as we're going to use this model to perform the customer churn inference. Now we've jumped to the predictive Python notebook, and we can see the first cell is a parameter cell. We'll use the run ID as a parameter so we can easily replace it in the future. Then we can run the predict function definition and run the model prediction. After verifying the predictive notebook, we plan to set up a data pipeline including this procedure, and we can easily create a pipeline from the Python notebook. After setting up the notebook activity name and the parameters we are using in the predictive Python notebook, we can save the data pipeline and start running the activity to validate the end-to-end flow. When execution is finished, we can click on the activity name and view the Python notebook run snapshot to verify the result. It looks like the notebook was executed successfully without any exceptions. Next, we can orchestrate the Python notebook activity with other activities to build the entire pipeline. That's all for this demo. Thanks for watching. Welcome to this demo of Fabric Notebook Live Versioning, a powerful feature that facilitates collaboration and reproducibility, making it easier for teams to work together and maintain a clear record of their progress on notebooks. Let's dive into the live versioning feature. By clicking the History button on Notebook ribbon, you can see the history of changes made to a notebook. We provide two types of checkpoints in this feature: automatic checkpoints and manual checkpoints. Here is an example of automatic checkpoints list. It was created every 5 minutes when the notebook has edits. The records are grouped by date. By default, you can expand it and easily track what changes were made, by whom, and when on the notebook. And by clicking on each record, you can compare current version and the previous version of notebooks side by side. This comparison includes code, output, and metadata, helping you identify and analyze the changes and validate the results. Similarly to automatic, the manual checkpoint also has a diff view. If a mistake is made or a different approach needs to be explored, you can restore the previous version. This can be done by either replacing the current version or creating a new copy of the notebook. This feature ensures you can recover from errors and experiment with different scenarios without losing the work. You can easily create a manual checkpoint by clicking on the plus version button. Just type a checkpoint name and some descriptions. You will be able to create a manual checkpoint to record your project milestones. We also provide version management functions. By clicking on the ... button on each record, you can easily operate actions like restore, edit, save a copy, or delete the manual checkpoint. Please note that the current version of Record is a read-only view of the notebook. You can view the result and play with the widgets, but all the operations won't be saved to the notebook. Thank you for watching this demo of Fabric Notebook live versioning. We hope you find this feature useful in your projects and collaborations. Stay tuned for more updates and features from Fabric.